Bismillahirrahmanirrahim. Assalamu alaikum. Students, I hope you are all fine. Today we will learn about rheostat. This is our next lecture, and in this lecture, first of all, we will define rheostat. Then we will discuss its working principle and its function. And most important things, physics is about how and why. Then we will see here what is the purpose of this rheostat and the construction, and in the construction the wire is made of magnet wire. Why we use this magnet wire? Let's start our lecture. First of all, we will discuss about the definition of rheostat. Rheostat can be defined as the wire wound variable resistor. What is meant by variable resistor? Here variable resistor mean that device which give us variable resistance. So if we need variable resistance, then we use it. The purpose of it, give the variable resistance. So we define it. The wire wound variable resistance is known as rheostat. Now we discuss the construction. What is the construction? Here the construction of rheostat is, it consists on insulator cylinder like here, and the bar magnet wire wound on it, and it has three terminals A, B, C, and C is the sliding contact. Sliding contact means it can slide, it can move over the cylinder. Now here is the diagram. This is the terminal A, second is the B, and the third terminal is C, which is movable. This is the terminal C, which can move from A to B. Now look at the diagram. This is the practical diagram of rheostat, and you will also do experiment in practical lab, and you will perform and find the resistance by using this rheostat. And here there are three terminals. First is A, and second is B, and the third terminal is C, which can slide over the cylinder. How it can slide? Watch here in the diagram. You see here terminal C can slide over the insulating cylinder. The wire which is wound over the cylinder is the bar magnet wire. This bar magnet wire is made up of alloy of different metals. It is a mixture of different metals. Why we use this magnet wire? Students, physics is about how and why. Now we see here why we use bar magnet wire. The bar magnet wire is used because it is strengthened and hardened even at very high temperature. That's why we are using here. Students, now we will discuss its working. Its working is based on two functions. The first function is variable resistor, and the second function is potential divider. So let's start our first function, which is named as variable resistor. It consists on simple wire which has three terminals A, B and C. It is the simple diagram of rheostat like this. This is rheostat, and this rheostat becomes a variable resistor. How it becomes a variable resistor? When we used A and C terminal, then it becomes a variable resistor. If you use other terminal, then it become other function. Now we have to use A and C so that it becomes a variable resistor. Keep in mind that you must use these two functions A and C for variable resistor. Otherwise it becomes any other device, any other function. Now look here, these are zigzag lines which represent resistance of wire. The wire is of same which is I mentioned you in rheostat. This rheostat on which wire is wound is represented by zigzag lines here, and the third terminal is C, on which it can slide from A to B and then B to A. In between A and B it can slide, it can move. Now how we can use it? Let its starting point is A. If starting point A is A, we know that the resistance is directly proportional to length. If the starting point A, at the point A the length is 0. If the length is 0, then resistance will also becomes 0. Now if I move terminal C from A to at this midpoint, let it is at midpoint, then this will the portion of wire, and this is the small length. So here this is the small resistance. You can say that the small length is increased, so small resistance is also increased. Now if I move this terminal C further away from A, then it will, suppose is at this point. If it at this point the length is increases, if length is increases, then resistance is also increases. So if I move it from A to B, the maximum length, there will be next maximum resistance. Now I shift C from B to A back. So when it is coming back to A, the length is decreasing. If the length is decreasing, then resistance is also decreasing. I mean here the by moving these terminal C, there will change in length, so there will change in resistance, which means it becomes variable resistor. It gives us variable resistance. If I need variable resistance, not fixed resistance, I am doing experiment and I need 2 ohm, then 10 ohm, then 20 ohm. I need variable resistance, then I use rheostat, and in rheostat I use first function, and first function can be used if I use A and C, these two terminals, and I am using these two terminals, and I am first I need low resistance, small resistance, then the terminal is C is near to A, the length is small, resistance is small, and if I need a high resistance, which I have to do, I will slide this terminal C from A to B, then length will increase, so the resistance will also increase. So I will receive higher resistance. This is the purpose of this rheostat. Now the second function is potential divider. How rheostat become potential divider? Now we use two terminal B and C. If we use B and C, then it becomes rheostat. So I mentioned here, use terminals B and C. If we use these two terminals B and C, then this rheostat becomes potential divider. What does meant by potential divider? Potential mean voltage, or here the divider mean divide. The potential will divide, voltage will changes, will divide. How it becomes, how it happens? Let's see. You know, this is the diagram, this is the simplest diagram of potential divider, which represent the rheostat. This is the rheostat, and this rheostat has simple diagram in this way, and see here, this terminal A and B and C. If I move this horizontal diagram into vertical, then it will become like this, which is potential divider, and we put here battery, and the terminal A here, the terminal B, and this third is sliding contact. You know, battery gives potential difference voltage, due to which current flow through this circuit, and we always consider conventional current, and conventional current start from positive terminal to negative terminal. So here current is flowing from positive terminal to negative terminal. If now check here, the B point is starting point. In first function, A was the initial point. Look here, this is A point in variable resistor. A was the starting point, but now we are discussing about potential divider, and in potential divider we used two terminal B and C in our circuit, and so now B becomes a starting point. Now if terminal C is moved from B to A, it is moving from B to A, so the resistance will increases. If resistance increases, the potential will change. How it can change? Look here at the derivation. We know about Ohm's law. What is Ohm's law? You know, according to Ohm's law, the result of Ohm's law is V is equal to IR, where V is potential, I is current, R is the resistance. I write it in general form, and you know, here potential is VBC. What is VBC? Look here, the terminal, let I move sliding contact, I move this sliding contact B to C. If it is at this midpoint, then these two terminals are here, and in these two terminals the potential difference is VBC. So what is VBC? VBC is the potential difference between B and C, which I put here. The second current which is represented by I, and the third term is resistance, and this resistance is represented by small r. What is small r? The small r, the resistance of portion between B and C. Look here, this is the B and C portion, and between B and C the resistance of wire is small r. So I put here small r. You know, here I put VBC. So this resistance is also used between B and C. The voltage is between B and C, so the resistance is also between B and C. I put here small r. You know, the voltage of battery is constant. This is battery whose voltage is V, and the resistance, the total resistance of this circuit, this wire, is capital R. V and R is constant. If I put here constant, this portion I highlighted in red dotted line, this complete portion is constant. If we multiply constant with this equality sign, then it becomes proportionality, and other are resistance and potential VBC. So it becomes potential is directly proportional to resistance. It means if resistance increases, then potential will also increases. How resistance changes? Look here, if I move this terminal C from starting point B, if this terminal C is at point B, then resistance is 0. If then resistance is 0, if resistance is 0, then potential also becomes 0. If the terminal C is at starting point, the resistance is 0, the potential VBC also becomes 0. Now I shift it away from B, that is moving towards point A. Now it is moving away from B. Let it is at this point. At this point, resistance increasing, resistance is increased. If resistance increase, then potential is also increased, because both are directly proportional. Now if I move this terminal C towards A, see, the total resistance becomes capital R. Now total resistance become capital R. If I put capital R instead of small r, then it will becomes VBC is equal to V our capital R, this is constant factor. Now we put capital R in place of small r, so capital R cancel with each other, then it will becomes VBC is equal to V. It means when the total resistance is in the circuit, then there is the total potential V is there. Now see, if this resistance changes, the potential is also changes. Potential changes mean potential is divided. It becomes potential divider. What is the purpose of this potential divider? The purpose of this potential divider is that if I need, I am doing experiment and I need different voltages. First I need 2 volt, then I need 10 volt, then I need 20 volt. I want different voltages in my circuit, in my experiment. Then first of all I need small voltage. Then I put this terminal C very near to B. Resistance is small, the voltage is small. Then I need large voltage. Then what we have to do? We move this terminal C away from B. When it moves away from B, then what happens? The resistance increases, so the potential increases. I use this potential in my circuit. This is the purpose of potential divider. Students, this is our today lecture, and now I put a link in the description of this video. You can watch the animation of video. This small portion of that animation I show here, and complete portion of this video you can watch in the description of this video. You can click on that link and then new video will open. Students, now we will see in next lecture. Allah Hafiz.